Hello and welcome back to the advanced course on R programming. In this tutorial, we're going to finally start learning how to use the apply function in R. So let's jump straight into it. The first question we want to ask is, what is the apply function? So let's bring up the help for this function. And if I open this window here and we zoom in a bit, you can see that the apply function has the following structure. So the word apply, x, margin, and fun. Fun, the third argument, is the function that you want to apply to your matrix X. And margin is specifying whether you want to apply it to the columns or you want to apply it to the rows. Or you can even apply it to the rows and columns. So here you can see that for a matrix, 1 indicates the rows. So if you want to apply a certain function, like let's say the average, find the average of certain rows, of all of the rows, then you'll say 1 in place of margin. If you want the average for columns, you'll say 2 in place of margin. And also you've got these optional arguments, which if fun requires optional arguments, you can pass them on after as additional arguments for the apply function. And here you can see that also a side note that in cases of functions like plus and matrix multiplication, subtraction, division, all those functions that don't have a name or actually have a symbol instead, then they must be backquoted or quoted. But we won't be delving into those kind of operations in our tutorials, so we won't stop on that. That's more of a side note for us. Okay, so there's our apply function. How do we use it? Let's get some hands-on practice. So we're just going to say apply, and then we're going to apply this to our Chicago matrix. So what do we want to do? We want to apply, we want to look at the average for our Chicago matrix. So let's just run Chicago first here. Here you can see that it's got 5 rows and 12 columns. We want the average for every row. How do we do that? Well, we specify the matrix here. Then we want to specify that we want to apply something to all of the rows. That means 1. 1 stands for rows. And then we want to tell the apply function what exactly it is that we're applying. And we're applying the average function, which is called mean. Now, we don't need any brackets after mean in this specific case when you're just passing the name of the function. So if you run that, there you go, as simple as that. So we've got 5 rows, that's why we have 5 results. For every single row, we've got the average. So we've got the average of those temperatures. The average high temperatures in Fahrenheit is 59.3. The average of the average low Fahrenheit temperatures, which are here, is 43.25, and so on. All right, so that makes sense. And you can always just quickly spot check this. So let's check it. You can say mean, and then you just choose one of these rows and run it for that. So let's say Chicago. Here we're going to say, let's look at the rows, which is called days with precipitation, and comma, nothing. So if I run this line, you'll see that the average for this row, if you calculate separately, is 9.916. And here it was also calculated as 9.916. So everything seems to be running smooth. Awesome. Now let's analyze one city in a bit more detail. What other functions can we apply? That's where the word apply comes from, because we're literally saying what other functions can we apply to this matrix. So there it is, Chicago, right? What other functions can we apply? Well, obviously we can look at the max, right? So let's do that. Apply Chicago 1 max. So that's the maximum values, and you can see here that is indeed 84 is the maximum, 68 was the maximum in this row, 4.13 was the maximum in this row, and so on. And then we want to apply same thing, Chicago, but we want to apply the minimum. So this will tell us what the minimum in each row was. Great. And now we're going to do the following thing just for practice, because it doesn't really make sense in our specific case, but we're going to look for the maximum in every column, right? It doesn't make sense here because this type of matrix is more kind of, actually it is more of a data frame and kind of flip data frame where every column or every row here is kind of a separate metric that we're looking at. So it's either this Fahrenheit temperature or precipitation in inches or days of precipitation. You shouldn't really be comparing them across each other. It doesn't make any sense whatsoever. But for practice purposes, we're going to do that. We're going to just see what the maximum or minimum in each of the columns is. So let's go ahead and do that. How would we do that? Well, we'll just say apply, and we'll say Chicago. Then we'll say 2, which is for columns. 2 stands for columns. Then we'll say max, right? So there we go. Of course, it has picked up this whole row as max because it's over 100 and the rest are under 100. And then you can do the same thing and just say min. So I'm just gonna say doesn't make much sense, but good exercise. So we just remember that this was an exercise. All right, and now what we're going to do is we're going to get a little bit of closer to what we've been asked to deliver, right? So we're going to compare some cities side by side. So let's take this line that we have here, Chicago with the average, and copy it a few times. So here we're going to change this to New York, and here we're going to say Houston, and here we're going to say San Francisco. All right, so now if I run these lines, let's just run them all one by one. 1, 2, 3, 4. You'll notice that we've come up with something very similar to what we are after. So we are after a representation of annual averages of every metric for every city. So we want to find, so like let's have a look at Chicago. So we need the average for this row, the average for this row, average for every single row. So that would be for Chicago, and we need to compare them across the different cities. And that's exactly what we have here. So here we've got Chicago, and we've got the average for every single row. New York, we've got the average. Houston, average. San Francisco, average. So already here, visually, right now, we can compare and we can say, okay, the average high Fahrenheit temperature was the highest in Houston, right? Annual average. Average of averages, actually. Then low, so the average of this column annually was the highest. Where was it? Also in Houston, and the lowest was in Chicago. And then precipitation, the highest was in Houston as well. Days with precipitation, interesting result. It was actually higher in New York, so more rainy days. And hours of sunshine, here you can compare and you can see that in San Francisco is the most sunshine. Now, this isn't, of course, the final result. We're very close. We can already compare these. Right now, we could have used something like cbind to bind these into a matrix to get our final result. However, we will instead progress through this section of the course, and you'll see that there are more methods that are available to you in your arsenal, and that can get you to that final result that we're looking for much quicker. So here I'm just going to say, let's make a comment here, step away a bit, and we'll say, so this is deliverable 1, but there is a faster way, right? So actually say nearly. So it's not the final deliverable, but it's very close. And further down in the course, in this section of the course, we will find that there are other ways to get to what we're after. All right, so hopefully this illustrates how powerful the apply function is, and we'll actually talk more about that in the upcoming tutorials. And I look forward to seeing you next time. Until then, happy coding.